Good morning. Our next area of concern that we are going to look at is angle properties of a circle. And this is one important area that is normally divided into two in the syllabus. We have angle properties of a circle, and then we have chords and tangent. Angle properties of a circle is done in Form 2. Chords and tangent is taught in Form 3. We are also going to separate the two. I'm not very sure, but I think it has also been done the same in the KCSE made familiar. Maybe you can check if they have separated. If they have not, we will still separate. We will do the questions separately. These are the objectives, what you are expected to know as a learner. You should be able to identify an arc, chord and segment. You should be able to relate and compute angles subtended by an arc at the circumference. You should also be able to relate and compute angles subtended by an arc at the center and at the circumference. Some of these things we are just revising. I know that you know them, so we will just brush through them. You should also be able to state the angle in a semicircle. You should also be able to state the angle properties of a cyclic quadrilateral. And you should also be able to find and compute angles of a cyclic quadrilateral. So these are the objectives. Remember, from these objectives, the examiners normally set questions. Let's look at one of the objectives. You should be able to identify an arc, chord, and a segment. An arc, as you can see in this diagram, is part of the circumference of a circle. A chord is a line from one point of the circumference to another. It does not cut through, it just touches the circumference. And a chord divides the circle into two parts. These are the parts we call the segment. The smaller part is known as the minor segment, and the larger one is known as the major segment. This one I believe you know. Let's look at the angles which are subtended by a chord or an arc. For this part, we normally talk mostly about a chord. About an arc, but we will combine both because they mean one and the same thing as far as the angles are concerned. But in the next part of the topic, we will be dealing more with chord. So angles subtended by the same chord or by equal chord on the same segment are equal. That one you know. Then the angles subtended by a chord or an arc at the center of a circle is double the angle which is subtended by the same chord on the circumference. So if the angle subtended by a chord on the circumference is x, then the one subtended at the center is 2x. I believe you are aware of that also. So if a chord subtends an angle of 50 degrees on the circumference, the same chord will subtend an angle of 100 degrees at the center. And for that reason, the diameter being a special chord, you know, the diameter passes through the center. It subtends an angle of 180 at the center, and consequently 90 degrees on the circumference, because the angle on the circumference is half the one at the center, or the angle at the center is double the one on the circumference. So we are using that property to show you the angles subtended at the center by the diameter and also at the circumference. I would like you to attempt this question here. it has suggested answers. So in this figure, BOD is the diameter of the circle. The center is O. Angle ABD is 30. Angle AXD is 70. Determine the size of the reflex angle BOC. The suggested answer is 280. See whether you can get it. Then find the angle ACO. You can pause the video, go through it, then you continue playing. In this figure, if you look at BOD, you are told is diameter. That means angle BAD is going to be 90. BAD is 90 because diameter subtends an angle of 90. You can draw a line joining A and D. You are also told that angle ABD is 30. So looking at triangle ABD, angle B is 30, angle A is 90. Consequently, 90 plus 30, you get 120. Subtract 120 from 180. So you get angle ADB. ADB, D for dog, ADB being 60 degrees. If that is the case, if you look at triangle AXD, now you know 60, you know the base angles. One is 60 and the other one is 70. 60 plus 70 gives you 130. So 180 minus 130, you get 50. So it means that angle XAD or DAX, which is also DAC, is 50. That one is subtended by which chord on the circumference? Angle A, there will be subtended by a chord CD or arc CD. And arc CD subtends which angle at the center? It subtends angle COD. So if angle CAD is 50, then angle COD is 100. Hope we are together. If that is the case, we want reflex angle BOC. And we know that the angles on a straight line. So angle BOD, which is a straight line, BOD is a straight line. So the angle there is 180 at O. So to get the reflex angle, you add the 100. That is angle COD. And you will get that angle as what? You will get it as 280. So that is how you get 280. The second part, we are supposed to get angle ACO. If you look at angle X on this other side, it's going to be 70. And already you know the other angle, angle COD is 100. So meaning 70 plus 100, you get what? 170. Then 180, you subtract 170, you get 10. So that means angle ACO is 10. That may not be the only way. You can use other ways, but I think there's a shorter way. Yours could be shorter than mine. It's accepted. These kind of questions don't really have a certain way of starting, so long as you use the rules which are there, and they are accepted rules, you get the answer correct. So the point at which you start doesn't matter. You don't have to follow my method of starting. You can start anywhere. You can start anywhere. Let's look at properties of a cyclic quadrilateral. A cyclic quadrilateral is a four-sided figure whose vertices touch the circumference of a circle. So the opposite angles of a cyclic quadrilateral add up to 180. In this example I have given down here, a cyclic quadrilateral is A, B, D, E. You can see the vertices A, B, D, and E touch the circumference of a circle. So opposite angles of a cyclic quadrilateral, meaning angle A and angle D, when you add them, they will give you 180. Similarly, angle B and angle E, when you add them, they will also give you 180. Basically, those are the properties of a cyclic quadrilateral that you need to know. And with that, you can be able to answer any question. Like this one here, you can attempt it, giving reasons, find the value of y in the figure below. Reasons are normally the rules we have learned so far. The angle subtended at the center by a chord is twice the angle of the circumference. That's a reason. Equal chords or equal arcs subtend equal angles. Then cyclic quadrilateral is here. Opposite angles of a cyclic quadrilateral add up to 180. And any other rules you know about plane figures. For example, the sum angles of a triangle is 180. Basically, those are reasons. So reasons, when you're asked about reasons in such a question, you are being asked to state the rules. As simple as that. Let's see here. You are asked to get y, and as you know, opposite angles of a cyclic quadrilateral add up to 180. So pause the video, get the value of y. The suggested answer is 29. It may or may not be correct. Just see it, just do. See whether you get that or a different answer. Hope you have gotten it. Now, let's go through it together. So, angle A and angle D, when you add them, you should get 180. So, if angle A is 3y, then angle ADB should be 180 minus 3y. Hope it's clear, because when you add both angles, the opposite angles of a cyclic quadrilateral, you should get 180. Now, the other angle, which is angle BDF, if you look at it, what will be the value of angle BDF? EDF is a straight line. So meaning angle EDB and BDF will give you 180. So if angle EDB is 180 minus 3y, then the angle on the other side of a straight line will basically be 3y. Because 180 minus 3y plus 3y, you will get 180 angles on a straight line. That means this angle here, angle BDF, is 3y. Let's now concentrate on triangle BDF. We have two angles in terms of y, angle D and angle F. Angle D is 3y, angle F is y. So when you add the two, you get 4y. Then you add 64. So 4y plus 64 should give you 180, sum angles of a triangle. That's the reason. So when you take 64 to the other side, you get 116. Then 4y is equals to 116. Divide 116 by 4. I think you get 29. You can check that. I hope it is clear. So that's how we use the properties of a cyclic quadrilateral. Opposite angles of a cyclic quadrilateral add up to 180. That is it for this part. It's a Form 2 review. So I would like you to attempt the questions in KMF in this topic from 2006 to 2019. I'm not sure whether they are mixed together with the ones for chords, but I would not like you to attempt any question that involves tangents or intersecting chords at this moment, because they will form the basis for the next lesson. So if you find a question with tangents, you should skip it. I think I need advice on this from the mother or anyone who is having a book somewhere near, to check on this. But if this topic is on its own, the better. So thank you, and may God bless the work of your hands.